First, I cut a piece of paper into a singular long, thin strip. I labeled the top corners of each side of the strip A and B, then the bottom sides of the strip C and D. I half-twisted the strips and connected the opposite sides in order to create a single twisted loop, a Mobius strip. The Mobius strip is a non-orientable shape. A non-orientable shape is one that has a path which brings the traveler back to his starting point, mirror reversed. In other words, a traveler following on the path of a non-orientable surface, in this case the Mobius strip, will essentially travel in a loop, but return to the starting point flipped in the opposite direction. Now I will demonstrate how the Mobius strip is non-orientable. I take a pen, starting at point A. I continuously draw a line on the loop until I reach my starting point without lifting my pen. As you can see, I've drawn on both sides of the loop. The Mobius strip is represented by several sine and cosine equations. R is the radius of the midcircle. Height is z equals s sine 1/2 t, where z equals 0. The length is x equals r plus s cosine 1/2 t times cosine t, and y equals r plus s cosine 1/2 t times sine t in the range 0 to 2 pi. The Mobius strip's area is considered a cubic surface, represented by the equation negative r squared y plus x squared y plus y cubed minus 2r xz minus 2x squared z minus 2y squared z plus yz squared equals 0. The Mobius strip is a three-dimensional shape. It is defined on the x, y, and z axes. The length, height, and area of the Mobius strip are calculated by using the values of the x, y, and z axes. So, you're probably wondering why the Mobius strip matters. In all reality, this shape can't do anything for you. But the Mobius strip has many practical applications. My favorite application is towards the cassette tape. It improved the recording ability of a cassette. Although we don't use cassettes anymore, this invention was groundbreaking for music lovers when it was invented. As you can see, the cassette is looped with a twist similar to the Mobius strip. Because of this loop, the tape can be recorded and play over and over again. Just for fun, I'm going to make a Mobius strip out of a bagel. If you like cream cheese, you should cut your bagel like this because the cream cheeseable surface area of the bagel increases. The way I'm cutting the bagel will create a two-twist Mobius strip. When the Mobius strip is altered, for example cut, twisted, or divided, rings called paradromic rings are created. Paradromic rings are analogous to the Mobius strip, with instead of one twist, have multiple twists. The rings are still a single surface just like the Mobius strip. This bagel is a great example of a paradromic ring. It is a two-twist Mobius strip. When I cut the bagel, two interlocking Mobius strips are created. The Mobius strip is an interesting shape. So interesting that it might even explain the shape of our universe. There are three possibilities for the shape of the universe: flat, zero curvature; spherical, positive curvature; or hyperbolic, negative curvature. Different theories, for example, the theory of relativity, explain the shape of the universe in different ways. In order to determine the real topology of the universe, it needs to be understood on a physical basis, how it is rather than a relative one, how we think it is. The reason why the Mobius strip is related to the shape of the universe is because the universe is perceived as infinite. Like the Mobius strip, it looks like one surface but is an optical illusion, so the universe might not actually be infinite. The universe is an example of a space that cannot be oriented. There is no way to see the entire universe. The Mobius strip is related to the universe in this way. When an object is on the surface of a Mobius strip, the reflected image of the object is indistinguishable from the original, just like how I showed the paper man walking around the Mobius strip. In the universe, it is impossible to orient yourself in a certain place. it is possible that you may have a mirror image of yourself on the opposite side of the universe, making it an infinite loop. The concept is difficult to grasp without physically experiencing it. The universe may be an infinite loop or an optical illusion. We might be living in a Mobius Strip universe.